This video is on exercise 9D A-level Maths Pure 2 textbook. Question 5. A curve C has equation y is equal to x minus pi over 2 to the power of 5 sine 2x in the interval that x is between 0 and pi. Find the gradients of the curve at the point with x coordinate pi over 4. Right, so by this time, so hopefully you've realized that these questions are very common, especially when you're dealing with differentiations. So whenever you have an equation and you want to find the gradient at a certain point, you just need to differentiate the equation, then substitute the x coordinate into that, because that gives you the gradient at that point. So here we should differentiate the equation y. dy by dx is equal to. So here is a combination of product rule and chain rule, because if you want to differentiate this, we should use the chain rule. And at the same time, we have two functions, because one is this function and the second one is this one. So that we should use the product rule at the same time. Now, based on product rule, we write the first function times the derivative of the second function. So our second function is sine 2x. The derivative of sine 2x is 2 cos 2x plus, now this time it's the derivative of the first function times the second function. So the derivative of x minus pi by 2 to the power of 5 is going to be 5 times 1. So 5 is the power and 1 is the derivative of x, because inside just differentiates to 1. And this times x minus pi by 2 to the power, reduced by 1. So 5 minus 1 is 4. And this is our derivative. And now we want to find the value of the gradient at this x coordinate. So when x is pi by 4, we have now it's the matter of substituting that into this equation and then just getting the final answer. So we write pi by 4 minus pi by 2 to the power of 5 times 2 cos 2 times pi by 4 plus 5 times pi by 4 minus pi by 2 to the power of 4. I just realized that I forgot to write sine 2x here, because that's the part of our differentiation. Because for the second bit, I should have written the derivative of the first function, which is this, times the second function, which is this. So yeah, I forgot to write sine 2x. That's all I missed. It's nothing new. And we should also have another term here, which is going to be this bracket times sine 2 times pi by 4, because that's our x coordinate. And so hopefully you can realize that here we are going to have cos pi by 2, and cos pi by 2 is 0. So that's 0 times this is just going to be 0. This entire thing is going to be 0. And then here, if we simplify this, we should get this exact value, 5 pi to the power of 4 over 256. So as you can see in this question, they haven't asked for any specific form for the final answer. So it's better to give your answer as the exact form, unless they've asked you for a rounded answer to maybe two significant figures or two decimal places, and so on. 6. A curve C has equation y is x squared times cos x squared. Find the equation of the tangent to the curve C at this point P in the form ax plus by plus c is equal to 0, where a, b, and c are constants, are exact constants. So here is very important. Okay, so we've seen a lot of questions like this, and here the only difference is the function and the differentiation rules that we need to apply here. So again, we have both chain rule and the product rule. So product rule for the entire function, because x squared times cos x squared, then chain rule for the second function because that's cos x squared. Right, so we have dy by dx is equal to the first function times the derivative of the second function. So the derivative of inside is 2x, so that comes out, then 2x times, so the derivative of the outer function, so cos differentiates to minus sine, so minus sine of inside. So this is the quick way of doing the chain rule. And so this is the first part, and in the second part we write down the derivative of the first function times the second function, and we can simplify this a bit. So here we have minus, or actually before simplifying, it's always good to check that if you can factorize, because it's going to be helpful, especially in questions like this that we are not dealing with very nice functions. And yeah, here we have a factor of 2x in both sides, so yeah, we can take a factor of 2x out, and that's going to be very helpful. So we take the factor of 2x out, so that we have minus x squared sine x squared, and this plus, so yeah, there is no need of this bracket now, and this plus cos x squared. Yeah, okay, so the x coordinate is root pi over 2. So when x is equal to root pi over 2, we have dy by dx is equal to 2 times x, so 2 times root pi by 2 times minus root pi by 2 squared times sine root pi by 2, and again squared, plus again an extra bracket. So yeah, plus cos root pi over 2 squared. Oh, yeah, this one was actually necessary for this week. So yeah, okay. Now we should continue the simplifying process. So we have now root pi outside times, so root pi over 2 squared is pi by 4, and this is negative, so negative pi over 4, and times, so inside the bracket again it's root pi over 4, and sine root pi over 4 is 1 over root 2, so this has an exact value, and this plus, so again inside is pi over 4, and cos of that is again 1 over root 2, and we'd better take a factor of 1 over root 2 out, and because that helps us to have a simpler expression inside the bracket. So if you take a factor of 1 over root 2 out, we will get root pi by 2 times 1 minus sorry, so I just made another error, and that is so when you have this and when you square this, you should get minus pi over 4. But here I mistakenly wrote a root pi over 4, so yeah, this root will be gone, and now inside we should have 1 minus pi over 4. So as you can see, it's very easy to make, you know, some very small mistakes in questions like this. And now we have this. So what is this? This is our gradient. And as you can see, we had to do a lot of, you know, simplifying to get this gradient. Now, the next step is using the general form of the equation of a straight line, which is this: y minus y0 is equal to m times x minus x0, where y0 and x0 are our coordinates of the points, and m is the gradient. So in this case, point P has the coordinates, so P has the coordinates root pi over 2 and pi root 2 over 8. Right. We also need the equation here as well. So yeah, we should use the general form to get the equation. Y minus y0, which is pi root 2 over 8, is equal to m, which is the gradient, and gradient is root pi over 2 times 1 minus pi over 4. So this is the gradient, and then this times x minus x0, which is the coordinate of the x coordinate of the point, which is root pi over 2. Right. So this is the equation, and unfortunately we cannot leave that in that form since the question has asked for this specific form. So we need to, you know, continue our simplifyings. And so we can start this by multiplying everything by 8 to get rid of this denominator on the left hand side. So we multiply each term by 8 and we get 8y minus pi root 2 is equal to 8 root pi over 2 times 1 minus pi over 4 times x minus root pi over 2. So before I move on to the next step, we can do something very interesting here. And that helps us to get rid of this 2 on the denominator of this term. So there is a rule that, for example, let's just write that here on top. So when we have a root b and we want to convert this into a third, so this is equal to a squared times b, right? I think this makes sense because we can split the thirds to root a squared times root b, and then root a squared simplifies to a root b. So as you can see, we have proved that. So now we can use this fact, and you know, here this is not necessary, so you can just continue and, you know, not do this, but yeah, I'm just going to do that here. So 8 squared is 64, and 64 times pi over 2 gives me 32 pi. So 32 pi. Now I can write this as root 32 pi So as you can see, I have gotten rid of the denominator. And again, I can convert this back into the simplified form now. So root 32 is equal to root 16 times 2, which gives me 4 root 2. So now I can convert that back into this form. And of course, we are going to have a pi term inside as well. But, that just gives us a, nicer term, if you like. So, which means here, by doing that, I will get 4 root 2 pi. So now what happens? Now, as you can see, here I have 1 over 4, sorry, pi over 4. So I can now, expand this. So 4 times, I can expand this and do 4 times 1 and 4 times minus y. So basically, multiply 4 by the first bracket. So by doing that, I will get 8y minus pi root 2 is equal to, so root 2 pi times, so 4 times 1 is 4, 4 times minus pi over 4 is minus pi, times x minus root pi by 2. Now let's expand the right hand side. So I have still 8y minus pi root 2 is equal to root 2 pi. And on the right hand side, I will get this times 4 minus pi times x. So, multiplying each term of the second bracket by the first bracket. And then I will get minus and root pi by 2 times. So here is important because we have this term, which is root 2 pi. And if you want to multiply this right here, instead of, just multiplying by that, we can, bring this into the play and, just because we have root pi and root 2 pi, so they cancel each other out, so that we should get x root 2 over 2 times 4 minus pi. Because root 2 pi times root pi gives us pi root 2 over 2, which is exactly this term. And now we can rearrange the equation so that we have 8y. So now let's take away root 2 pi times 4 minus pi times x from both sides, so that we have this x term on the left hand side as well, minus root 2 pi times 4 minus pi times x. And now let's add this value to both sides, so we will also have the c term on the other side as well. So we get plus pi root 2 over 2 times 4 minus pi root 2 is equal to 0. And that's it, because the question was asking for this form for the final answer, and now ours is exactly the same. So this is ay, this is bx, and this is the c. So of course we can simplify c, but it's not really necessary here because this is just a constant. And that's it for this video. So thank you for watching. Make sure to subscribe for the future videos, and good luck.